electric field. By the end of this session, you must be able to 1. Describe electric field. 2. Draw electric field lines of various configuration of charge. 3. Define the magnitude of the electric field at a point. 4. Deduce the force acting on the charge in an electric field. 5. Calculate the electric field at a point due to the number of point charges. Electric field is a region in space in which the electric charge experiences a force, and the direction of the electric field is the direction which a unit positive charge will experience if placed in the electric field. Electric field is a region in space in which an electric charge will experience a force. So if we can put an electric charge here, if it's positive, it will go this way. If it's negative, it will go this way. So it experiences a charge. And we determine the direction of the electric field by using a small positive charge, a unit charge, of course, a unit charge. So a positive charge will move in that direction. So hence the arrows are facing in that direction, which is the direction of the electric field. From a positive charge, the electric field radiates or diverges from the charge, while in the negative charge, they converge towards the charge. Look at the points. It's pointing this way, with this one is pointing out of the charge. Field lines. Arrowheads indicate the direction of the electric field. Away from the charge if it's positive, and towards the charge if it is negative. The stronger the electric field, the closer the field lines. If you can look close to the charge, the field lines are close to each other than away from the charge. So the electric field is stronger close to the charge than away from the charge. Field lines never touch each other. So there's no way of which this line will ever touch each other. Field lines are perpendicular to the surface of the charge. The strength of the electric field is directly proportional to the magnitude of the charge. Field lines from a positive charge to the negative charge. The space between the lines becomes bigger away from the charges. You can look here. As you go away from the charges, the field lines becomes bigger. The field lines never cross each other. Field lines curve away from the charge. That is the field lines between the like charges. The field lines curve away from each other. The space between the lines becomes bigger away from the charge, and field lines never cross each other. Electric field at a point. Electric field at a point is defined as the force experienced by the test charge at that point. The force experienced by a unit positive charge at that particular point. Let us use the definition of electric field at a point and Coulomb's law to show that the test charge has no effect on the magnitude of the electric field. According to Coulomb's law, the electrostatic force is equal to the Coulomb's constant times the product of the charges divided by the square of the distance between the point charges. By definition, electric field is equal to electric force per charge. And making the electric force the subject of the formula, we get that electric force is equal to the electric field multiplied by the charge. Substituting equation 2 in equation 1, we find that electric field times the charge is equal to Coulomb's constant multiplied by the product of the charges divided by the square of the distance between them. Note, the small q represent the small positive charge. So on both sides, we've got the small q. Dividing both sides by q, we find that electric field is equal to Coulomb's constant times the charge divided by the square of the distance between. We divide by the square of the distance from the charge to that particular point. Worked example. 2-point charges Q1 equals to positive 3 microcoulomb and Q2 equals to minus 4 microcoulomb are separated by a distance of 0.2 meters. A. Calculate the electric field at the point located 0.1 meter to the right of Q1. That Q should be capital. On the x-axis, B. If the small positive charge Q equals to plus 1 nanocoulomb is placed at point P, what force does it experience due to the electric field? Please try to do this before you're looking at the solved example.